Hi, my name is Nicholas Espinal. This is the third question from my Chapter 29 quiz, and this is what it asks. A 50-centimeter wire placed in an east-west direction is moved horizontally to the north with a speed of 2 meters per second. The horizontal component of the Earth's magnetic field at that location is 25 microteslas toward the north, and the vertical component is 50 microteslas downward. What is the EMF induced between the ends of the wire? So first off, when we see a question like this, we want to visually represent it. We want to illustrate the problem. To the left of the screen is going to be the north, and pointing out of the screen and in is the east and west direction. So pointing to the left, you'll see that the wire is moving with a speed of 2 meters per second. It's moving to the north with a speed of 2 meters per second. And they also tell us the components, the horizontal and vertical components of the magnetic field of the Earth at that point. So they give us the horizontal component is 25 microteslas, and the vertical component is 50 microteslas. So this would give us a resultant magnetic field. And from here, we could already tell that this is what the actual magnetic field would look like in this situation. But we have to be mindful though, because this, as we know already, that if this wire is moving in the direction of a magnetic field, meaning that it is parallel with that magnetic field, nothing is going to actually affect it. The magnetic field is not going to have any type of effect if this wire is moving in a direction that is parallel to the magnetic field itself. So you're going to see that this is not the magnetic field we're going to be working with, even though that is what the magnetic field looks like in the situation. What we're actually going to be worrying about is only this component, because this horizontal component is parallel to the horizontal movement or motion of this wire. So this magnetic field pointing in the horizontal direction, the horizontal component of the magnetic field is not going to have any effect in our calculation. So what we're only going to have to worry about is the 50 microteslas component of the magnetic field that is perpendicular to the motion of the wire. Now, because of the wire being in motion, the EMF is a motional EMF. And this is described by the velocity of the wire times the magnetic field that it's in, and the length of the wire. And again, we use the component of the magnetic field that is perpendicular to the wire's motion, which is only 50 microteslas. And we also have the velocity of the wire, which is 2 meters per second, and the length of the wire, which is half a meter, or 50 centimeters. So we can use all these values, just plug it into the formula to find motional EMF, and that's 50 microvolts. So if we look in our answer choices, we'll see that the choice E is the answer, 50 microvolts. And using that idea of motional EMFs and knowing which component of the magnetic field to use helped us solve this problem.